Hello everyone, here I am back again. Sorry about the delay. We have we have been talking about set theory and systematic counting, and I went through the basics in previous lecture. Now let's take a look at some more elaborate and advanced issues. So I'm going to take a problem from the old textbook. Here we are. Systematic counting, sorry about that. I'm going to take a look at this problem here. Now, let's take a look at the one in the exercises. So we're going to do problem 17 of the exercises here. So students were asked to name their favorite Free Regina newspaper. This is our universe, is what? Is the students who were surveyed. This is the result of the survey. 33 like the Carillon, 32 like the Metro, 28 like the Prairie Dog, 11 like Carillon and Metro, 15 Carillon and Prairie Dog, 14 Metro and Prairie Dog, 5 like all three, and 7 like none of the newspapers. So we're going to try to put that data into our Venn diagram. So here is a Venn diagram to represent the data. There are now 3 categories. Carillon, Metro, and the Prairie Dog. And you see there's a more complex kind of overlapping. All 3 can overlap, which is what happens right here in the middle, or just 2 can overlap outside of a third. Or there can be categories that are in exactly one but not the other, either of the other 2. And then out here is a category of students who don't like any of the newspapers. All right, so here's the data. I'm just going to copy it from the question. 33 like the Carillon, 32 like the Metro. Uh, 33 like C, 32 like M, 28 like the Prairie Dog. Let's go back to the data here. 11 like C and M, 15 C and P, 14 M and P. 5 like all 3 and 7 like none. All right, so we want to assemble this data into our Venn diagram in a way that makes sense. And the numbers that go in the Venn diagram are all going to be different from these numbers, or many of them are going to be different from these numbers. Okay, so let's try to start with something that's going to be the same. All 3 newspapers, 5 students liked all 3 newspapers. So that means there's 5 in that center region that overlaps all 3 of my sets. Now let's take a look at, say, the Carillon and the Metro. There's 11 students in that category, but I've already counted 5 of them. See, the Carillon and the Metro is this region here. It's kind of moon shape. Oops, I want to undo that. Undo. Get rid of that one. Okay, there's 5 already counted, so this number has to be 6. 6 plus 5 is 11. Okay. Similarly, C and P is 15. 5 is already counted, so this number is 10. 10 plus 5 is 15. The M and the P is 14, but 5 are already counted, so this number has to be 9. Okay. So I've used 4 of my data items, and I've got 4 numbers assembled, but notice, like I said, most of the numbers are different from what you see in the original data. Okay, now we're ready to tackle a big guy here, Carillon. 33 like the Carillon. How many have I counted already? I've counted 10 plus 5 plus 6. That's 21 have been counted already. 33 altogether, so that is 12 more. 12 plus 10 is 22, 27, 33. Right, so that is a bit of a calculation. And it's not obvious that that number is 12 until you do all the work, all the subtracting that needs to be done. Okay, use that piece of data. The Metro 32, well, I've got 9 and 5 and 6. That's 20 altogether so far. 32 adds another 12 in this category. And that's kind of a coincidence that those two are number 12s. There's 28 that like the Prairie Dog. How many have I counted already? I've got 10, I've got 15, I've got 24, so that means there's only 4 more that I haven't counted yet. Finally, 7 like none, well, that's out here. So that number I just copy. It's unusual for these problems to have a number that you just copy, but sometimes it happens, so there we go, 7. And that has used all the data. And now I can start answering questions about it. So let's take a look. How many students took part in the survey? Well, that would be the sum of all of these numbers. So let me see, there's 7. Let's just work our way from the bottom up. 7 and 4 is 11. And 9 is 20, 30, 35, 41, and 12 is 53, and another 12 is 65. 65 students took part in the survey. Okay. How many students only like the Carillon? Well, that's the students that are in this category. Only like the Carillon, don't like the other 2. That's this category here. That would be 12. Finally, how many students like exactly 2 newspapers? Well, here's the 6 that like the 2 Carillon and Metro, and here are 10 that like Carillon and Prairie Dog, and here are 9 that like the Prairie Dog and the Metro, so that is 6 plus 10 plus 9 is 25. Like exactly. So you can answer pretty much any question of this type just by referring back to the Venn diagram, locating the parts of the diagram that are relevant, and maybe adding a few numbers or subtracting a few numbers to get the answers to these kinds of questions. So you should now try a few of those on your own. There's a few here in here's a survey of 100 University of Regina students. There's also this problem in the text here, the students studying different math topics. So you can take a look at those. Okay, so that is almost it. There's just one little bit left. I'm going to scroll down here because the set theory stuff is spread out a little bit in this textbook. Here we go. I was just looking at it a little while ago. Probability. It was in 5.4 appendix. Here we go. Yeah, so this is an interesting example. It uses the similar, uses ideas from Venn diagrams, but it adds a little bit. So I think it's a nice topic. It's a very important topic anyway, blood types. So there's in the 1930s, it was discovered that people were having trouble with blood transfusions because people were developing allergic reactions. If they got a transfusion that wasn't compatible with them twice, people could die from severity of the allergic reaction you get from incorrect blood transfusion. So this was investigated by a medical doctor named Karl Landsteiner. And he sorted it all out, and we still use Landsteiner's blood classification system now. There are additions to it, but the general idea is still used now. So that's what I'll give. So we have the universe of people with blood here, and to make it precise, we'll just look at, say, Canadians. So here's all Canadians, and I'm going to draw my Venn diagram shape, and these are represent different factors that can occur in the blood. So there's been identified numerous factors, but the most important are A, B, and D. D is also sometimes called rhesus. A and B are always just called A and B. And these are probably, as far as I know, I'm no expert in biology, but it seems that they are related to immune system activity. And so people with a factor or a antigen in their blood have a certain type of immune response, and people with B antigen have a different immune response, and some people have both, and some people have D and not D, and so on. You can get actually any combination of these different factors in your blood. But it's usually not expressed in that manner. So those with just a factor alone are said to have type A blood. Those with factor B alone have type B blood, and those with factor D alone have O blood. Except it's a little more complicated than that. There's two A's actually. There's this A and this A here. And those who have the D factor get a plus, and those who don't have the D factor get a minus. The same for the B's. Those with the D factor get a plus, and those without the B factor get a minus. And then there's those who have both A and B factors. We're going to put the ABs here, AB, AB. And as usual, without the O, without the D factor, I mean, you get a minus. With the D factor, you get a plus. And we'll put a plus here for the O positive, and out here is O negative. So this is our blood type classification. These symbols A plus or minus, B plus or minus, AB plus or minus, and O plus or minus are given to the 8 regions of this Venn diagram. So an O minus is someone who has none of the factors, no factor, and they're also known as universal donors. And the reason for that is that it's safe for anyone to get O negative blood because the O negative blood does not have any of these antigens that cause allergic reactions. So anybody can take O negative blood, and that's why O negative blood type is a universal donor. This is very important in medicine. If well, suppose you have a emergency paramedics, they drive around with a supply of blood in case they come across a patient who needs a blood transfusion on the spot, or at least needs blood on the spot, is losing blood. And they don't have time to do tests. If it's an emergency and someone's rapidly losing blood, they can't do blood tests to find out what antigens they have. So they just grab O negative blood. And so emergency paramedics, other emergency situations are stocked with O negative blood. So it's very important to have a big supply of O negative blood. And if you have O negative blood and the Canadian Blood Services finds out, well, they're like vampires, they're after your blood. So you should probably go donate blood very often if you have O negative blood. It's the most valuable kind of blood. On the other hand, if you get AB positive blood, you've got every antigen, and that's a universal recipient. And lucky for you, because you can accept blood from anybody. There's no incompatibilities. You can accept blood from any other blood type, and they may have the antigens or they may not that you have, but you are not ever going to have an allergic reaction to other people's, anyone else's blood that's donated to you. So lucky for you, universal recipient. Your blood is actually not so useful to be a donor because the only people that can take AB positive blood are people with AB positive blood already. So it's not good for a donor, but it's great to be a recipient. And similarly for O negative blood, you're unlucky as a recipient because you can only take O negative blood. You can't take any other kind of blood because it has antigens and can cause that allergic reaction. I actually know somebody who this happened to. They got the wrong type of blood. I don't know how these things happen in modern medicine, but they do. Blunders happen. She got the wrong type of blood. I guess this happened in the United States. And she got very, very sick from getting the wrong type of blood. And they told her that, the doctors told her if it ever happened again, she would probably die. So it is an extremely serious thing. Yeah, okay, so that is our blood type classification. Now, we're going to take a look at some of the data that's given in the textbook and see if we can assemble our Venn diagram. So here we go. 46%. So these are not numbers. These are not counts like they were in the previous example, the Carillon and the newspaper example. But these are now percentages. Well, we can work with percentages too. So let's do it. 46% have blood that contains the A antigen. So I'm going to draw another diagram here with the numbers, not the symbols, but the numbers. Here's my A, here's my B, here's my D. 46% have A antigen. It's not the same as the number that have the A blood type. This is just the antigen data that we're looking at. 12% have B, 85% have RH. I've been calling that D, but RH and D are synonymous. 3 have A and B, 38.5 have A and RH. Now the number has just slid right out of my head here. 3% have A and B, 38.5 have A and RH. %, have B, and rhesus, and 2.5% have all three antigens. All right, so let's try to assemble that in our diagram. The easiest one is the one that has all three. The numbers doesn't change, so that is 2.5% goes in here. I don't know if I like that there. Okay, 2.5%. Okay, now I'm going to start working my way backwards here. 3% have A, I should label these A, B antigen, and D antigen. 3% have A and B. I've already counted 2.5%, so that means 0.5 goes up here. The total of those two numbers is 3%. Correct. 38.5 have A and D, so 38.5 are A and D, but I've already counted 2.5 of them, so that is 36% are in that other space. Total of 38.5 A and D, yes. 10% have B and D, so 7.5 is going to go here, plus 2.5 is 10%. Correct. All right. 46% have the A antigen. Let me see how many I've counted already. I've counted 36 plus 3 more is 39. So that means 7% are out here. 12% have B. How many have I counted? Let me see. I've counted 3 plus 7.5 is 10.5, and that means 1.5. Adds up to 10. 12, sorry. Because this is 10, 10.5, 12. Okay, good. And 85% have D. How many have I counted already? I've counted 10 plus 36 is 46. So how many to make 85 is, what is that? 85 minus 46 is 39. All right, we've used our data, and these spaces correspond to percentages of blood types. So let's see, how many AB positives is 2.5%. How many A negatives? 7%. So we can read all that data. Now, if you think carefully about this, we're missing something. What is the O negatives? It's very important for us to know. I'd love to know how many people are O negative. And I have no number. So this is where we have to use our noggins a little bit. This is different from that previous question I did about the newspapers, because when I said the newspaper question, I gave that number. how 7 students didn't like any of those newspapers. But here, that information is just absent. But in this case, we use the property that 100% is everybody. So this space here can be obtained by adding up all these other numbers and subtracting them from 100%, because the total of the whole diagram, the total of the universe, has to be 100%. So let's go through this. This is 85. It should be, because that's, well, let's just double check it. 60, 75, 85. Yes, 85 in this D circle. And there's 2 more here, so that's 87 plus 7 more is 94. So that would put this number out here at 6%. I hope I did all the arithmetic correctly. 6%. Let's double check that and add them all up. So 6 and 39 is 45. And 36 is 81, and 10 more is 91, 98, 98.5, 99.5, 100%. Okay. So let's try to answer the questions now. What percentage of Canadians are universal donors? We worked that out. That is 6%. That's people who have no antigens, universal donors. What is the set of blood types that can receive blood from a donor classified as A positive, and what percentage can receive A positive blood? So here, here is A positive, but who can receive A positive blood? We'll go back to the previous diagram here. Oops, I gave you the wrong, shoot. This is A positive, of course. Those have both the A and the rhesus factor. Sorry. So here's A positive. Who can have A positive blood? Who can receive A positive blood? In order to receive A positive blood safely, you have to have both the A factor and the rhesus factor. And the only people who have both the A factor and the rhesus factor are this moon shape here. Let's go back and look at the percentage. That would be 38.5. So that's still something, but it's not, certainly nowhere near 100%. So 100% of people can receive O negative blood, but only 38.5% can receive A positive blood. And so you can think about this and make a chart for all the different blood types and get some idea how valuable they are in relative terms. And here is the reverse question. Describe in set notation the set of blood types that are acceptable to a person classified as A positive. What percentage of Canadians can donate blood to a person classified as A positive? Well, if a person is classified as A positive, who can donate who can they donate to? No, that's the question we just answered. Who can donate to them? who can donate to somebody classified as A positive? Well, anybody without the B antigen. So they have to have the A antigen or the D antigen, but not the B antigen. Anybody who doesn't have the B antigen. So here is all the people who have the B antigen here. So those who don't have it are the O negative, O positive, A positive, and A negative. And we look at our chart here. That'd be 6% plus 39% plus 36% plus 7%. So that would be 45%, 52%, 88%. Okay, so some interesting questions there. Anyway, that is it. We have finished the course. I hope you enjoyed it. Now there's a question of quiz 5, which I still have to assemble. I will get to that soon. I think it'll be ready Friday. I'm hoping. If not, then Saturday, and you'll have a week to finish it. It'll also help you study for the final exam. And as I mentioned at the beginning, quiz 5 will be on fractions, fraction operations, lowest terms or least terms, and conversion of fractions to decimals. This new material will not appear on quiz 5. This new material will appear on the final exam, though. And the final exam will take place at the specified time. It will be for the specified amount of time, 3 hours. I will send out notes to everybody through the news forum about all of these things when they're ready to go. All right, so anyway, have a good Easter weekend, long weekend. Try to relax this weekend. Enjoy yourself a little bit, even if you can't see your family in person, then at least you can connect over the face phone, as my mother says. I think she's trying to say, what is she trying to say? FaceTime, but she calls it the face phone. So have good face phone this weekend, and I will keep in touch.